Okay, so today we're going to talk about differential equations. One comment I'd want to make about differential equations is that differential equations is it's such a large topic where we pretty much have a whole class of its own. So what we're going to do is we're going to talk about basic differential equations for this class, and we're going to solve probably the most basic differential equations. The more complicated ones are left over for the class if some of you get the opportunity to take it. So let's define what a general differential equation is. So we can say that a differential equation is an equation that contains an unknown function and one or more of its derivatives. So basically, what we're saying is we have a function and we don't know much about that function, but we're given an equation that has that function along with its derivatives. And then our goal is to find that function specifically. So for example, we could say something like f cubed plus 3f or f triple prime plus 3f double prime plus f equals to, I don't know, 5, for instance. So here's what we're saying. We're saying find a function where when you find its triple derivative, 3 times its double derivative, plus its function, where it equals to 5. So you're trying to find a function that satisfies this equation. And so this is what a differential equation is. So it's a function compared with or combined with its derivatives, and you want to find a function where this condition is satisfied. Okay, and of course it's a differential equation. And to be honest with you, we've worked with differential equations in this class plenty, but we've worked with the most basic differential equations. So let's talk about the order. The order of is basically of a differential equation is the highest derivative. So for example, this example I gave you above, the order of this is 3 because the triple prime, that's the highest derivative we have. So this actually has order of 3 because that's the highest derivative. Okay, so basically what we want to do here now is we want to work with differential equations. So in this section, for the most part, you're going to be given the solution for a differential equation, which means they'll give you the function, they'll say verify that it is a solution. In later sections, we will be finding the solution ourselves. So it won't be something as complicated as this guy, but I'll give you an equation such as this, and I'll tell you, okay, find what f is. Okay, so that's kind of like the main idea here. You have some equation with a bunch of derivatives, and your goal is to solve for this differential equation, or essentially we're trying to find f. Okay, so for our first example and our only example, we're going to say, look, show that y equals to 1 plus a constant times e to the t divided by 1 minus a constant times e to the t is a solution of y prime equals to 1/2 times y squared minus 1. Now look at what's happening here. Why is this a differential equation? Because I have the function y, which I don't know what it is, and I have the derivative of y. So this definitely is a differential equation. Not as complicated looking as that, but it still is a differential equation. So what are we trying to do? We're trying to find the solution of this. Now, what's the problem here? The problem is or there is no problem. The way that this problem is asking us to approach it is they're giving us the solution. They're saying, look, verify that this in fact is the solution of that. So in other words, what are we saying? If I take this and I find its derivative, that should be the same thing as 1/2 times y squared, which is this guy squared minus 1. So let's actually verify this. So to show that, we're going to start off with this guy, and let's find y prime. So y prime will be, we have to use what? The quotient rule. So the derivative of the top, now remember 1 and c are constants, t is the only variable. So it'll be what? ce to the t times the derivative of the bottom minus the derivative of the bottom, which would be negative ce to the t times the top all over the bottom squared. Okay, so now let's simplify a little bit. What could I do from here? Notice how I could factor out a ce to the t, and if I factor out a ce to the t, what am I left with? 1 minus ce to the t minus negative 1, or let's actually just say, well, negative 1 times 1 plus ce to the t all over 1 minus ce to the t squared. So these negatives become a plus, so what do I get? I get the 1 plus 1, which is 2, negative ce to the t plus ce to the t, those will cancel out. So what does this become? This becomes 2 ce to the t all over 1 minus ce to the t quantity squared. And so what do we just show? Y prime is equal to that. So now we say, okay, well, what am I claiming here? Since this is a solution of that differential equation, in other words, y prime, which we found, should be the same thing as 1/2 y squared minus 1, because this is my differential equation. So now let's verify it. We're saying, okay, let's go now to the differential equation and say we have y prime equals to 1/2 y squared minus 1. So now, since we know what y is, I'm going to replace 1 plus e to the t, 1 minus e to the t in place of y. That becomes 1/2 times 1 plus ce to the t over 1 minus ce to the t quantity squared minus 1. So what does that give us? We get 1/2. 1 plus ce to the t squared will be what? 1 plus 2 ce to the t plus c squared e to the 2t over, let's just leave this as 1 minus ce to the t quantity squared. Now, why didn't I distribute the bottom? Because look, this is already matching up with that, so I'm not going to mess with the bottom. This is minus 1. So now let's get a common denominator. So the common denominator is just 1 minus ce to the t squared to the top and bottom, which that gives me 1/2 times 1 plus 2 ce to the t plus c squared e to the 2t. And if this is minus 1 times 1 minus ce to the t squared, what is that going to be? That's going to be minus 1 plus 2 ce to the t minus c squared e to the 2t all over 1 minus ce to the t quantity squared. So if you're wondering how I made the jump from here to here, I just got a common denominator here. I multiplied the top out and I got to this. So now I'm going to move on to the next page. Now, if we keep simplifying, what do I get? If I just combine the numerator from above, what do we get? We get 1/2 times the ones will, so if I bring this back, what do I notice? The ones will cancel out. The negative c squared e to the 2t and the c squared e to the 2t cancel out. So what do I have? 2ce to the t plus 2ce to the t, which becomes 4ce to the t all over 1 minus ce to the t quantity squared, which then the 1/2 and the 4, they cancel out. And what do I get? I get ce to the t over 1 minus ce to the t quantity squared. So there you have it. In fact, this matches up with what we did earlier, which was, oh, and this 1/2 and the 4, this 2 should be there also. That matches up with that. So sure enough, what did I do? We validated that this right here is the solution of that differential equation, because what I did is once I plugged y into here, I saw that when I simplified this, that was the same thing as finding the derivative of that. So in this case, they kind of gave us the solution and they said verify it. But later on in this class, what's going to happen is this isn't going to be given to us. They're going to give this differential equation. They're going to say, find the solution. And then we're going to have to grab this and work backwards and find that. Okay, so that's with the later sections to come. So in this section, for the most part, they'll give you the solution and they'll ask you to verify that it's a if it's a solution to the differential equation. So once again, the main idea in this section is to work with differential equations. And what does that mean? It just means simple things such as like, hey, I'll give you something like, hey, y prime equals to yx, for example, and I'll say, okay, find out what y needs to be. Now, why is this a differential equation? Because I have an equation of a function y that I don't know what it is, as well as its derivative. And my goal is to find out what y is. And this is fine. X is okay to be in there because x itself is an independent variable. Okay, so you won't be able to solve something like this today, but you will be able to solve something like this in the upcoming sections. Okay, so that's basically it. That's basically what differential equations are. Now, I know that this wasn't that long of a lecture, and just keep in mind that differential equations are it's such a big topic where it's a class of its own. So we'll learn how to solve differential equations, but we won't get into like the hardy stuff where we get into a lot of detail and the more complicated differential equations. So just remember, anytime you're asked to solve a differential equation, you will basically be able to use your calculus knowledge to solve it, and we won't go too far beyond that. Okay, and if you need to solve more complicated differential equations, you'll learn that when you take the differential equations course yourself. Okay, so that takes care of this section.